Okay, so today we're going to take a deep dive into something super exciting in the AI world.
That's good.
It has to do with large language models.
Okay.
You know, LLMs, right? Like
Yeah.
the smarts behind all those fancy text generators and chatbots you keep hearing about. They've gotten so good at like understanding and generating text,
Yeah, they have.
even showing some pretty impressive reasoning skills. Fuck models like OpenAI's O1 and DeepSeek's R1.
Right.
So if you're interested in like the cutting edge of AI, this is definitely something you want to wrap your head around.
Absolutely. These LLMs have made like huge progress in their ability to process information and solve problems.
Right.
All thanks to the mountains of data they're trained on.
Yeah, they've got so much knowledge packed in there.
It's amazing how they can connect all these different pieces of information.
No, right? It really is.
Yeah.
But okay, here's the thing.
Okay.
There's this tricky part, this challenge we're going to really dig into today.
Yeah.
Even with all that built-in intelligence, these models struggle when they need to actively search for new info to tackle really complex questions.
Okay.
The kind that need multiple steps and pulling in knowledge from the outside world. So in a way, they're not as well informed as we'd like them to be.
Right. Like imagine a brilliant mind stuck with only the books they've already read.
Exactly.
Yeah, that's a big limitation if we want to use LLMs for real world problems.
Yeah.
They're amazing at using the data they have, but so many questions need information from outside their training data.
It's like they need to hit the library, right?
Exactly. And getting them to effectively use external search with their reasoning, well, that's been a major hurdle.
Which brings us to the heart of our discussion,
Okay.
a new approach called ReSearch.
ReSearch, okay?
Think of it like teaching LLMs to reason with search.
Interesting.
And what's really cool is the method.
Okay.
It uses reinforcement learning to do this without needing tons of data explicitly showing the model how to think or when to search.
Gotcha.
So if you've ever wondered how AI can overcome its current knowledge limits, this could be a game changer.
Yeah. ReSearch offers a whole new perspective on how an LLM can interact with the massive amount of info online.
Okay.
It's not just about retrieving information and then trying to answer. It kind of blurs the line between thinking and searching.
So could you give us the quick rundown on the basic idea behind ReSearch?
Sure. So essentially, ReSearch makes searching a core part of the LLM's thought process. It's not a separate step.
Okay.
The model's own thinking guides what it searches for, and the results then influence its next thought and how it eventually crafts an answer.
So it's like a back and forth.
Exactly. A constant cycle of thought and information gathering.
I like that, thought and information gathering.
Yeah.
Okay. But you mentioned reinforcement learning, RL.
Right.
For someone new to AI, how does RL help ReSearch teach an LLM this whole search and reason thing effectively?
So that's a great question. In ReSearch, we use RL to train the LLM by essentially letting it experiment with different strategies.
Oh, okay.
We don't specifically tell it, first think about X, then search for Y.
Right.
It learns over time which approaches work better through trial and error.
So it's kind of like throwing the LLM a puzzle and letting it try different ways to solve it?
Exactly. And then we reward it when it gets closer to the right answer or uses a smarter approach.
Gotcha.
Now, during these experiments, ReSearch uses something called rollouts.
Roll out.
Yeah, and these aren't just the final text answers you might normally see. A rollout in ReSearch is like a detailed record of the model's attempt at a question.
Okay.
It includes its thinking steps, marked with think tags, the search queries it makes, enclosed in search tags,
Okay.
and the search results, it gets back tagged with result.
So it's like the LLM showing its work every step of the way.
Exactly, that's a good way to put it.
I like that.
So a single attempt to answer a question becomes this sequence of thinking, searching, getting results, and then thinking some more.
Wow. So it's really that iterative process that's key
Yeah.
to teaching the model to reason with search.
Absolutely. The LLM generates these rollouts, trying different combos of thinking and searching, and then it gets rewards based on how accurate its final answer is
Okay.
and whether you use the right structure with those tags.
So it's being graded on both content and presentation.
Exactly.
But how does it know what's a good answer if we're not giving it step-by-step instructions or labeling the right reasoning paths?
That's where the specific RL algorithm they use comes in. Group Relative Policy Optimization, or GRPO.
GRPO.
And the technical details of GRPO are pretty advanced, but the main idea is this.
Okay.
Instead of needing a separate AI to judge each attempt the LLM makes, GRPO looks at a group of attempts and figures out which ones were better relative to the others.
So it's like self-assessment in a way.
Kind of. It's like the model learning from its own successes and failures within a set of tries.
Without needing an external judge for every single move.
Right, because building a good reward judging model is hard and might introduce bias.
Yeah, that makes sense.
So the LLM learns by comparing its own attempts, figuring out what worked better, and refining its strategy.
Okay, I'm following so far.
Now, another thing to keep in mind is the search results themselves aren't made by the LLM.
Right. They come from an external search engine.
Exactly. And that's where a technique called retrieval result masking comes in.
Interesting name.
So when the system is evaluating the LLM, it ignores the actual content of the result tags.
Okay, why is that?
This prevents the model from just copying from the search results.
Oh, I see.
We don't want it to be a fancy cut and paste machine.
Right, we want actual thinking and understanding.
Exactly.
But you mentioned those special tags like think and search.
Yes.
How do you make sure the LLM actually uses them right during learning?
That's where prompt templates come in.
Okay, prompt templates.
These are carefully written instructions showing the LLM the desired format for its responses.
So it's like giving a student a template for a research paper.
Precisely. Making sure they include all the sections and format it correctly.
When you're outlining your thoughts, put them in think tags. When you want to search, use search tags, that kind of thing.
Exactly. The researchers made two main prompt templates. One for base LLMs,
Okay.
those not fine-tuned to follow instructions,
Right.
and another for instruction-tuned models.
Gotcha. So those are already better at following commands.
Exactly.
Okay.
And what's interesting is these templates are actually pretty simple.
Really?
Yeah, they got inspiration from the structure used in DeepSeek R1. Shows that even with super advanced AI, clear communication through formatting is still key.
So no matter how smart they get, they still need good instructions.
Exactly.
So for a base model, you basically feed it the question with this template, and it guides the whole thinking and searching process.
Right.
And for an instruction-tuned model, the template is more like a system-level instruction, setting how it should approach the whole task.
Yeah, you got it.
All right, so the LLM is trying different approaches, learning through rewards, and using these templates to structure its attempts.
Right.
But let's talk more about those rewards. How are they actually calculated?
All right, so the reward system in research has two main parts.
Okay.
First is the answer reward.
Makes sense.
It looks at the final answer from the LLM, which should be in those boxed tags, and compares it to the actual right answer using something called the F1 score.
F1 score, okay.
In simple terms, the F1 score measures how well the predicted answer matches the true one.
Okay.
It considers whether it includes all the right info and if it includes any wrong info.
So it's like a balanced measure of accuracy.
Exactly. The closer the match, the higher the reward.
Makes sense?
The second part is the format reward.
Okay, format reward.
This is smaller, and it's given even if the final answer is wrong. As long as the LLM used all the right tags, think, search, result, and answer,
Yeah.
and put its final answer in those boxed things.
So even if the answer is wrong, it gets a little bonus for following the format rules.
Exactly. It encourages the model to learn the proper structure, even if it doesn't get the facts right away.
It's like learning the mechanics before mastering the content.
Exactly. They even set specific values for the rewards.
Oh, really? What are they?
Full F1 score if the answer is right.
Okay.
0.1 if the format is correct, but the answer is totally wrong.
Gotcha.
And 0 if both are wrong.
So the incentives are clear.
They are. It's about rewarding both reaching the destination and following the map.
That makes sense for teaching a complex skill.
Right.
The paper talks about testing research with experiments.
Yeah.
What AI models did they use to train and evaluate it?
So they used several versions of the Quen 2.5 model.
Okay, Quen 2.5.
It's a fairly new and pretty capable LLM.
Uh-huh.
They used a smaller version with 7 billion parameters
Okay.
and a larger one with 32 billion.
Wow, 32 billion.
And for each size, they used both the base model and an instruction-tuned version.
So that was already better at following instructions.
Exactly. So we can see how research works across different model complexities and starting skills.
That's a good approach.
Yeah.
But where did they get the data to actually train these models with research?
Interestingly, they only used one data set called music.
Just one.
Yeah. And it's specifically designed for multi-hop question answering,
Multi-hop, meaning?
where you need to connect info from multiple texts to find the answer.
Ah, okay, I see.
And the fact they only use this one data set is important.
Why is that?
It helps us understand how well the skills learned through research can transfer to new types of questions and info.
So it's about testing its ability to generalize.
Precisely.
So they trained it on one type of challenging question and then tested it on others.
Right.
What were those other data sets?
They used 4 benchmark data sets for evaluation.
Okay.
All focused on multi-hop question answering. Hotpot QA, 2-wiki multi-hop QA, music itself.
To see how well it did on the training data?
Right, and Bamboogle. But here's a crucial detail.
Okay.
For a Hotpot QA, 2-wiki multi-hop QA, and even music, they removed the original context documents.
Oh, wow. So the models had to rely entirely on searching.
They did, which really isolates whether research is teaching effective search and reasoning, not just memorization.
That's clever.
Yeah, it is.
So how did research stack up against other methods for getting LLMs to answer these complex questions?
They compared it against several baselines,
Okay.
like no-rag,
No-rag, what's that?
basically just using an instruction-tuned model without any external search.
Oh, okay.
Then naive rag,
All right.
a more basic approach where you first search for documents and then feed them to the LLM to answer. And 2 more advanced methods for multi-step reasoning with retrieval, IRETGen and IRCO.
Okay, and RAG stands for?
Retrieval Augmented Generation, a common way to enhance LLMs with external knowledge.
Gotcha.
So this gives a good range of comparisons from no search to more sophisticated techniques.
Yeah, I see.
Good spectrum.
And how did they actually measure performance? What metrics were they looking at?
They mainly use 2. Exact match.
Okay.
A strict measure where the answer has to be exactly the same as the correct one.
Word for word.
Word for word.
Wow. That's tough.
It is. But because search results can be phrased in different ways,
Yeah.
they also used LM as a judge.
Okay. LLM as a judge. How does that work?
They used another powerful LLM, specifically GPT-4 Mini,
Oh, interesting.
with instructions to judge if the answer was semantically correct.
Gotcha. So even if it wasn't word for word, did it capture the same meaning?
Exactly. This gives a more comprehensive view of the answer quality.
Makes sense.
So we've got the setup, models, data, the challenging tests, and the ways they measured it all.
Yeah.
Now for the big question, did research actually work?
Right. Did it deliver?
The results were impressive across all 4 data sets.
Wow.
And both the 7 billion and 32 billion parameter models, base or instruction tuned.
Okay.
Research consistently beat all the baselines.
That's great.
Yeah, it was better on both exact match and LLM as a judge scores.
By how much?
They saw average improvements of around 15 to 18 percentage points for the 7 billion models,
Wow, that's huge.
and about 14 to 15 for the 32 billion models.
Compared to the best baseline.
Yes, a really significant jump in accuracy.
So the models that were already good at following instructions got even better with research.
That's right. Training from those instruction-tuned models led to even better performance overall.
That's interesting.
It suggests that being able to understand instructions helps the model learn this complex reasoning and search process.
It's like a head start.
Yeah, and importantly, research was strong across all the data sets, showing its ability to generalize.
Right. It wasn't just good at the specific questions it was trained on.
Exactly.
Which is super important for real-world applications.
It is. You need a model that can handle a wide variety of questions.
Absolutely. So for anyone learning about AI, this generalizability is a big deal.
It is.
But the paper also goes deeper into the learning process.
It does.
What insights did they get from looking at what was happening inside the models during training?
So they looked at things like how the length of the model's reasoning process changed.
So how much text it produced within those think tags?
Exactly.
Okay.
They also looked at the number of searches it performed. And generally, the length of those reasoning steps increased as training went on,
Okay.
especially for the instruction-tuned models.
So as they got better, they were thinking more deeply.
It seems that way, maybe engaging in more detailed thought to break down the questions.
That's really cool.
Yeah, it is.
And what about the searching? Did they learn to search more or more effectively?
Yes, the number of searches consistently grew throughout training.
So they were definitely using search more and more.
They were. It became a key part of their strategy for answering these complex questions.
But there was that interesting thing with the 32 billion models, right?
Right. They actually saw a slight decrease in reasoning length initially.
Why was that?
They think those larger models might have first tried relying more on their own vast knowledge.
Like trying to solve everything from memory.
Exactly. But as they got feedback through the rewards, they likely learned to leverage external info more.
Which then streamlined their initial thinking.
That's their theory, yeah.
It's like they realized searching was more efficient.
Yeah, it's fascinating. Like they learned to use the right tool for the job.
I like that.
Yeah.
They also looked at those reward curves, right?
Yes, the training and validation reward curves.
What do those tell us?
They showed a sharp increase in reward very early in training,
Okay.
meaning the models quickly learned the basics of the task, how to get better, and how to structure their responses.
Gotcha. So they learned the rules of the game quickly.
Exactly. And after that initial jump, the reward kept growing more gradually.
So steady improvement over time.
Right. Showing continued progress in accurately answering those complex questions.
Makes sense.
And again, the instruction-tuned models started with higher initial reward.
Reinforcing that, being able to follow instructions gave them an advantage.
Exactly.
So it seems like all the evidence points to research being a really effective training method,
It does.
both the performance gains and the analysis of the learning process.
Yeah.
Now, the paper has this case study that really illustrates how it works in practice.
Right.
Can you walk us through it?
Sure. So the question was, who won the 2018 presidential election in the country where the political party of Martin Ramirez Pech operates?
Okay, so it's a multi-hop question.
It is.
You need to figure out the country and then who won the election there.
Exactly. It's not a single fact you can just look up.
Right.
So the research model starts thinking. Think. To find the answer, I first need to determine the country where the political party of Martin Ramirez Pech operates. I will start by searching for Martin Ramirez Pech to get more information about him. Think.
Okay.
Then it search Martin Ramirez Pech search.
Right.
And the first results are actually about a different person named Martin Ramirez. Yeah, but here's the cool part.
Okay.
The model thinks some more.
Think.
It appears that my initial search query was too broad and returned information about a different Martin Ramirez. To find the correct information, I need to be more specific and include the context of his political party. I will modify my search query to Martin Ramirez Pech political party to get more relevant results. Think.
So it realized its mistake.
It did, and decided to refine its search.
Wow, that's pretty amazing.
It is. And it did this all on its own through the reinforcement learning.
That's some next level AI reasoning.
I know, right?
It wasn't programmed to debug its search, it learned to do it.
Right. Pretty impressive.
So what happened next?
So it does the corrected search, which finds that Martin Ramirez Pech is with the Labor Party,
Yeah.
PT, in Mexico.
Okay.
And then it thinks again. Think. Now that I know Martin Ramirez Pech is associated with the Labor Party, PT, in Mexico, I need to find out who won the presidential election in Mexico in 2018. Think.
Makes sense.
Then it searches for 2018 Mexican presidential election. Finds that Andres Manuel Lopez Obrador won.
All right.
And finally gives the answer. The final answer is box Andres Manuel Lopez Obrador. Answer.
Wow, so we see the whole process laid out.
Yeah, the multi-stage reasoning, the searching, the integrating of info.
And that moment of self-correction is just mind-blowing.
It really is. It shows the power of this learning through feedback approach.
So to sum it all up, what's the key takeaway about research?
I think it's this new way of training LLMs to really integrate reasoning with search.
Okay.
And doing it through reinforcement learning without needing those step-by-step data sets.
Right, that's huge.
It's a big step toward overcoming the limitations of current LLMs.
Yeah.
Especially when it comes to answering complex real-world questions.
That need up-to-date info and multi-step reasoning. And the experiments clearly show it works.
They do. Significant improvements in performance and handling new questions.
Really impressive results.
Yeah, and beyond the performance, the emergence of those advanced reasoning skills, like reflection and self-correction.
Yeah, that was super cool.
It hints at a future where AI can learn and problem solve much more dynamically and autonomously.
That's exciting.
It is. And they even talk about future directions.
Oh, yeah, like what?
Expanding it to more tasks and incorporating other tools beyond just web search.
So much potential.
There is.
So for all of you listening who are interested in AI, think about this.
Go ahead.
If LLMs can learn to seek out and use knowledge like this on their own,
Yeah.
what could that mean for AI in different fields? In learning itself, in research, in solving complex problems everywhere?
It's a big question.
It is a really thought-provoking one.
Yeah,
And research like this is bringing us closer to answering it.
for sure.
Thanks for joining us for this deep dive.
It was fun.
Until next time.